Welcome back to the channel. In this lecture series, we've been looking at different sensors that have been used in automation of the cars. They have been some portion of the ADAS systems of cars, automatic cars. So in this video, we'll see about speed sensors. So what are speed sensors? How do they work? And what are the different types? And what are their application areas? And maybe their drawbacks as well, and what is the future for this speed sensor. We'll look at all of these in depth. Okay, start off the things that we'll be discussing are about just the introduction for what are speed sensors, what is the construction mechanism of speed sensors, the working principle, the different types of speed sensors, applications, advantages and disadvantages as said earlier. So to start off, the speed sensor is a very important component that should be on board the automatic cars. So what it does is it allows the magnetic rotation speed to be measured in order to provide a voltage corresponding to rotation speed. That is, let's say we have the wheels wheels are rotating, right? So the speed sensor will be placed next to it. So based on the rotation of the wheels, the rotation is due to the magnetic field present and electric voltage current is generated. Thus the voltage change is corresponding to the rate of the rotation. So based on that, the voltage that is obtained will be used to find out the what rotation speed of the wheel. Correspondingly, we can find out what is the speed based on that. It is widely used in the aeronautics, automotive, engineering sectors. The construction of speed sensor is just that. Most common wheel speed sensors, they use ferromagnetic tooth relictor rings. So the relictor rings will be there, and a sensor which can be active or passive that detects the change in the magnetic. I mean, yeah, that changes the change in the magnetic field, and thus a voltage will be obtained in the. Thus the voltage will be produced through the sensor. The tone wheel is typically made of steel and maybe an open assist design or seal. So the number of teeth will determine the speed of the vehicle, and also the range of the sensing and accuracy of the sensor, and also what will be the high speed as well. So if the number of tooth in the relictor, if it is more, greater number of teeth will require more machining operations and thus produce a higher frequency output signal, which may not be easily interpreted as at the receiving end, but giving a better resolution and higher signal update. So the more number of teeth it will take time and but it will give you a better resolution and a higher signal update as well. In more advanced systems, the teeth can be asymmetrically shaped to allow the sensor to distinguish between forward and reverse rotation of the wheel. So it can be in opposite directions. Now, we do not know necessarily in which direction it is rotating if the wheel is just rotating. So in the modern systems, the teeth are aligned asymmetrically, have like asymmetric shapes. So the direction in which they are rotating can uh, can give us information on which direction the wheel is rotating as well, not just the speed. A passive sensor typically consists of a ferromagnetic rod, which is oriented to project radially from tone wheel with a permanent magnet at the opposite direction. The rod is wound with a fine wire which experiences an induced alternating voltage as the tone wheel rotates, as the teeth interfere with the magnetic field. The passive sensors will give like sine output, which grows in magnitude and frequency with wheel speed. A variation of passive sensor does not have magnetic backing, but rather a tone wheel which consists of alternating magnetic poles producing alternating voltage. The output of this sensor tends to resemble like a square wave rather than like sine wave, but still increases in magnitude as the wheel speed increases. So the square wave will become the amplitude will vary based on the speed of the rotating wheel. So how it works? Um, the vehicle speed sensor measures the rotational speed of the gears in your transmission system. So here you see the toothed part, right? and here you see the slots, and here you see the pickup coil where and here is the sensor. So when the sensor so it shoots and gets reflected back here. So when there is low speed, you can see that the frequency is, the wave is bit sparse and it is spread apart. When it is high speed, it is they are cramped together and there is a high frequency. So this difference will be sent to the ECU part of the car, that is the electronic control unit. So what are the different types of speed sensors? There is the one magnetic speed sensor that we discussed now. There will be optical speed sensors, which instead of giving the magnetic, finding out the based on the magnetic part of the sensor, giving out the voltage output. Rather than that, the optical sensor, what it does is it might shoot some method of optical light. Maybe it is IR, it is a laser light, or it might be microwave as well, or it might be just normal visible light. So what will happen is it will be reflected back, and based on the tooth cutting it off, we can find out the frequency and thus the speed of the vehicle. Then we have Hall effect and gear tooth. Gear tooth might be similar to the magnetic one. And then we have transmission speed sensors, wheel speed sensors, ABS wheel speed sensors, and angular speed sensors. So the applications are that since it is the basic idea is that on the onboard systems, the magnetic rotation speed is corresponded to its voltage changes based on the rotation. So that based on, as the working principle is much simpler. The It is widely used in aerospace engineering, automobile, and precision engineering sectors, where we need to know the speed of the rotary components. The advantages are that variable reluctance sensors are passive sensors as they do not need external power supply. So we do not need to get like external power supply. The wire and magnetic system are they are very cheap. So the final sensor cost is also less, and thus it enables wider. It can be applied in a lot of application areas since it is very less expensive and also lightweight. So it can be used in harsh environments as well. But the disadvantages are that the target material must be ferrous only. So only then it will be like magnetic. As the magnitude of the induced voltage in these sensors is proportional to target speed, it becomes difficult to design circuitry appropriate for very low speed signals. Thus, variable reluctance sensors have a definite lower limit on the speed target. Higher limit, it is easier, but when you go in the lower limit, it becomes difficult. Those sensors themselves are cheap. The cost advantages offset because the initial cost is high, and electronic circuitry and the ECU part, ECU integration, and all of these might uh, add up on the cost as well for the manufacturing and assembly as well. Thank you.